Okay, so we've all gotten pretty used to asking an AI a question and getting an answer back, right? It's simple, it's fast. But what if AI could do way more? I mean, what if it could be a truly autonomous partner, one that could plan, act, and tackle complex goals all by itself? Well, that's exactly the promise of something called an LLM agent. And today, we're going to tear it down and see exactly what makes it tick. Let's just make this super clear from the get-go. On one hand, you have a chatbot. You ask it the capital of France, it says Paris. Done. But an agent? An agent is a whole different ballgame. You can give it a really complex goal, like plan my entire vacation, and it just runs with it. This isn't just about answering questions anymore. It's a huge shift towards actually achieving outcomes for you. So, at its heart, an LLM agent is an autonomous system. You've got the large language model, the LLM, acting as the brain of the whole operation. It's coordinating everything, memory, planning, and a bunch of tools to get the job done. And the keyword here, the one you really got to remember, is autonomy. It can work through tons of steps without you having to hold its hand the entire way. Right, so how in the world does an agent actually pull this off? Well, it all comes down to a few core components that have to work together perfectly. So let's pop the hood and take a look inside. This right here, this is the agent's engine in action. It's this constant operational loop. It's not just a one-and-done thing. The agent thinks about the task. It acts by using a tool, it sees what happened, and then it does it all over again, tweaking its plan as it goes. It's this continuous cycle of thinking and doing, until the goal is achieved. And this whole loop is powered by what we can think of as three critical pillars, all managed by that LLM brain. You can almost think of them as the agent's mind, its conscious, and its hands. And we're going to start with the mind, its memory. First up, let's talk about memory. And honestly, this is an absolute game changer. Without a memory, an agent would be totally useless. Kind of like a person with amnesia, starting over from scratch every single second. Memory is what gives it context, what lets it have a real conversation, and most importantly, what allows it to learn from its experiences. Now, an agent's memory isn't just one thing. It actually has two types. There's a short-term memory, which is kind of like a little notepad for what's happening right now. And then there's the long-term memory. Think of this as a massive, permanent library where it stores everything it's ever learned. We're talking knowledge that can stick around for years. And the big difference here really comes down to capacity. That short-term memory, it's limited. Information can get lost pretty easily. But the long-term memory, built with something called an external vector store, is practically infinite. It's vast and scalable, and this is what lets an agent truly build up knowledge and get smarter over time. So how do these two memories actually talk to each other? That's where this cool process called Retrieval-Augmented Generation, or RAG, comes into play. You can basically think of RAG as a super fast librarian. Whenever the agent needs some info for its current job, RAG zips over to that giant long-term library, finds the most relevant stuff, and pulls it right into the agent's short-term focus. It's brilliant. Okay, now we're getting to the really wild part. An agent doesn't just act based on what it already knows. It can actively learn from what it does, especially from its own mistakes. This is where the power of self-reflection comes in, and it is fascinating. And this is a really important question, right? Simpler AIs, they might just fail and give up. But an agent is designed to learn from those failures. It can figure out what went wrong and, crucially, understand how to do it better the next time around. The secret ingredient is something called reflection. It's a metacognitive process, which is a fancy way of saying the agent literally thinks about its own thinking. This is that conscience we mentioned earlier. It's like an inner voice that lets it review its own work, spot errors, and figure out how to improve. This is what could unlock truly autonomous AI. And this whole learning thing follows a pretty neat cycle. The agent tries a plan, it checks the results, and then, here's the magic, it performs a reflection. It literally writes a critique of what went wrong. And that lesson doesn't just vanish. It gets permanently saved in its long-term memory, making the agent smarter for literally every single task it does in the future. But look, a brain that can think and learn is totally useless if it can't actually do anything. And that's where tools come in. This is what gives the agent its hands and its voice, letting it reach out and interact with the digital world around it. Tools are what let the agent break out of its little digital box. With a toolkit, it can search the live internet for up-to-the-minute info. It can do complex math with perfect accuracy, and it can even talk to your team by firing off emails or sending Slack messages. So how does a thought actually become an action?
It happens through a process called function calling. The best way to think about it is like a universal translator. The agent comes up with a plan in plain English, and function calling translates that plan into a structured language that other programs, like your calendar or your email, can understand and execute perfectly. Now, with all this power, you gotta ask, how do we make sure these things act safely? Well, that's where something called the role comes in. It's basically a foundational set of rules we give the agent. It defines its personality, its skills, and most importantly, its ethical guardrails and boundaries. All right, so we've seen all the pieces: a mind that remembers, a conscience that reflects, and hands that can act, all quarterbacked by that LLM brain. Let's put it all together now and take a look at what this really means for the path to true AI autonomy. But all this incredible intelligence doesn't exactly come for free. The more advanced an agent gets, especially when it's doing that self-reflection thing, the more computer power it needs. And what that means is every lesson the agent learns for itself also costs a little bit more to run. And look, before these agents are just a seamless part of our everyday lives, there are some pretty big engineering challenges we have to solve. We need to make sure they're rock solid and don't break easily, that their knowledge isn't out of date, and that they can actually understand the tricky nuances of human language without getting tripped up. And all of this leaves us with one final and kind of provocative thought. When you have an agent that can reflect on its own performance, critique its own mistakes, and then update its own memory, well, in a very real way, it's teaching itself. And that just raises a fascinating question about the future of a technology that doesn't just follow our rules, but actively learns and grows all on its own.